Hi friends, in this video we solve supermesh related problems. Let us see the first question. Find the current I in the circuit. So this is the circuit. We have to find current I. So here we have a current I. So this current only we have to find. It comes under the category of supermesh because we have one current source in between the two loop. So we can say it is a supermesh. One current source is common current source is common between two loop. So this branch is supermesh branch, right? So this mesh form supermesh. So how to solve this problem? Let us see. So I assigned current for this loop as I1, here I2, fine, here I3, here I4. Okay. So now you see these two are forming, these two mesh forming a supermesh. So what I do, time being I ignore this branch which is forming a supermesh and I apply KVL for this loop. After that I apply KCL for this branch. Okay, let us see how to solve this problem. So first we apply KVL for loop 1. KVL for loop 1 is given by, you see here we start with minus. Here the current flowing through this resistor is I1 and I3. So V is 2 into I1 minus I3. Next in this branch it is 3 into this current I1 comes here, I3, I2 comes opposite. So I1 minus I2, and this current entering negative terminal. So it is minus 30 volt. That is equal to 0. Okay, this is loop 1. Fine. For loop 2, you see here, let us start from here. So it is 6 I2 minus this current here in this way, the current flowing in this branch is here I2 is flowing, opposite side I4 is flowing. So I4 plus here I2 is flowing in this branch, I2 is flowing here, no, here I2, 3 I2, I1 is flowing opposite. So 3 I2 minus I1 is to 0. Okay, now this is for KVL for loop 2. Now I apply KVL for supermesh. Right, this color is indicating supermesh, so I start from here. So first I apply KVL for supermesh 4. Here I3 is flowing, so 4 I3. Next here 8, so 8 I4 is flowing. Here in this branch I4 is flowing, I2 is flowing in the opposite side. So 6 I4 minus I2 plus next this branch here I3 is flowing, right? I1 is flowing in the opposite side. So 2 into I3 minus 1 to 0. Next what we have to do? We have to apply KCL for this branch. Okay, what is that branch? Here you see this branch is forming a supermesh. So what we have to do here, this is here I2 is coming, yes or no? So here I2 is coming. Okay, so this is okay. From here, if you apply here, it will create confusion. Let us apply here. So this is I3, this is I4. So what I do, I am applying here I3 is coming, here I4 is going, here 4 ampere is coming. So I3 is equal to, sorry, I3 plus I4. Incoming current is equal to outgoing current as per KCL. So we have to apply KCL at this branch. Incoming current is I3 plus 4 is equal to I4. So this is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4, right? So we have 4 equations and I1, I2, I3, and if you solve this equation, what we get is I is equal to I1. Yes, because I1 is flowing in this direction. If this is the current they ask I. So I is nothing but I1. That will be given as 8.5 ampere. 8.56 ampere. Simple problem. Hereafter it is simple mathematics. You can simplify and find the answer. Okay. Next problem is find V0 and I0 in the circuit. Okay. How we are going to solve this problem? I have to find I0. This is I0. This one I have to find. This V0 I have to find. And you see one current source, dependent current source is common between two mesh, so it is forming a super mesh. So these two are forming super mesh. Okay. Now we apply what you call KVL to find the answer. So let us assume this is the current flowing through this mesh. This is the current flowing through this mesh, and this is the current flowing through this mesh. Okay. Now apply at loop 1 KVL at loop 1. Let me start from here. It is what you call I1 so this is 1 ohm, so 1 into I1 minus I3 here. Next, for this I start from this is the super mesh. I apply KVL at a like okay, sorry, it is not a loop, super mesh. Okay, KVL at the super mesh is 1 I1 minus I3 here 2, right? Here current flowing through this resistor is I2, this I3 is flowing opposite, so 2 I2 minus I3. Here current flowing through this 2 I1, so 2 I1 that is equal to 0. Okay, so here there is one voltage source that is 16, current enters to positive terminal, so it is 16. Okay, so this is equation number 1. So here current is I1 minus I3 multiplied by 1 ohm, so voltage drop we got. Here I2, this current I2 is flowing in this, I3 is flowing in opposite direction, 2 into resistance is 2, so 2 I2 minus I3 plus 16 volt, here 2 I1 only. Okay, this is the first point we have to know. Then what we have to do, we have to apply KCL at super mesh branch. So this is KCL we have to apply. Here current coming, what is the current coming through this? If you take here, it will create confusion. So what we have to do, we take KCL in the bottom. So you see here I2 comes, here I1 goes, here 2 I0. Yes or no? So from this, if you see what happening here is incoming current is equal to outgoing current. This implies I2 is incoming, outgoing is 2I0 plus I1. KCL. KCL at the super mesh branch. Okay, so this is equation number 2. Okay, next what we have to do, we have to apply KVL at the loop 3. KVL at loop 3, that is very simple. This is I3 current flowing. I start from here. So 3 I3. Next here I3 is coming in this side, I2 is coming in that side. So 2 into I3 minus I2. Right, next here I3 is coming in this side, I1 is coming opposite side, so plus 1 into I3 minus I1. Fine, so what is happening? That is equal to 0. Fine, so this is third equation. So we have a 4 variable, I1, I2, I3 plus I0. So we have to see what is I0. So from this diagram, because this is one more equation with the variable I0. Fine. So from this we can see I0 is opposite to I1. So I0 is minus I1. Now we have 4 variable, 4 equation. Substitute I0 value here. Substitute 4 into and we get 3 equation. So then if you simplify by using the system of linear equation Cramer's rule, we will get what is the answer we are getting is I1 is equal to minus 32 by 3 minus 32 by 3 ampere. I2 is equal to 16 by 9 ampere. Okay. Okay. Now what we have to do? So first we have to find I0. I0 is equal to minus I1. So from here, so that is equal to I1 is minus 32 by 3. So it is 32 by 3 ampere. So we got I0. Next what we have to find V0. So you see in this branch here, if you see what is happening, right? I apply KVL in this branch. This 2I1 here I1 minus right. So 2I1 plus I1 minus I3 is equal to V0. Right or not? So I apply KVL at this branch. What I write? I apply KVL right here. Then only you will understand. So 2 from here I start 2I1 plus in this branch 2I1 here I1 minus I3 1 into I1 minus I3 fine. Yes or no? So that is equal to what happens 3I1 minus I3 here the drop is it is plus it is minus, so voltage is plus V0. So plus V0 is equal to 0. Yes or no? So I apply KVL in this branch, in this loop. So 2I1 plus I1 minus I3, this is plus minus, so it is total voltage drop is V0 they are telling, so it is V0. This implies V0 is equal to I3 minus I1. Okay, sorry, V0 is equal to I3 minus 3I1. 3 minus 3I. Okay, so V0 is equal to I3 minus 3I. V0 is equal to this I3. Okay, fine. Okay, I3 is 16 by 9, right? So we got okay, fine. So so you please make the changes here. Sorry for the wrong answer. I2 is what we get is I2 we got as 32 by 3. I3 is 16 by 9. Okay, so this is what answer we got. If you substitute all the values and we got I1, I2, I3 is like this. So I3 is in this equation, if you substitute I3 is 16 by 9 minus 3 I1. I1 I minus 3 I1 is what do you call minus 32 by 3. Fine. So if you simplify, V0 is equal to 33.8 volt. Okay. So this is V0 value. Okay. Next problem. Find I1, I2, I3 in the circuit. It is directly they have given the loop current we have to find. So here you see, here we have one current source is common between two mesh, so it forms a super mesh. So loop 1, loop 2 and loop 3 form super mesh. So what we have to do? We have to combine this and apply KVL. Fine. Okay, so let us solve this problem. Okay, first what we are going to do? Okay, we apply KVL at loop 1. KVL at loop 1. This is I1, so it is loop 1. So when you apply KVL, here let us start from here. It is I1 is flowing in this direction. I2, this current is I2. I2 is flowing. This current is I3. I2 is flowing in opposite direction. So for this branch, 2 into I1 minus I. Here plus 6 into I1 minus I3. Clear or not? So this is 6 I think this is 4. Next, this is minus 2 is equal to 0. Sorry, as per the problem, this resistor is 4. So 4I1 minus I3. So please change this. 4I1 minus I3 is equal to 0. Okay. Next, we apply KVL at supermesh. KVL at supermesh. This is forming a supermesh. Okay. So here you see what happens. Let us solve this. Here, this, let us start from here. From here to here we have to start. So 8, this current is I2 plus this voltage drop 2V0. Here 4 ohm I3 minus 1. Next here what happens? Here 2 into in this branch 2. Here current is I2. Opposite is I1. So 2 into I2 minus I1 is equal to 0. Why? Here this I2 only flows through this. I2 and I1. I3 flows through 4 ohm. So I3. I1 is opposite. So minus I1. So this is what we want. Next what we have to do? We have to apply KCL at super mesh branch. So we will draw the circuit first. This will be like this. What happens here? I2 is coming here. 2V0. Okay. So what we have to do? This is I2, this is I3. So let us assume the supermesh is like this, right? You see, I have drawn this one. Here I2 is coming. Here I3 is going. This is 3 ampere. So I have drawn this branch. Okay. So 3 ampere. I2, this current is I2, we know. This is I2. This current is I3. So what happens? Incoming current I2 plus 3 is equal to I3. So this is equation number 1, this is equation number 2, this is equation number 3, and we have V0. So this is V0, this dependent source, we have to know what is V0. V0 is given here, V0 it is nothing but here current coming is I1. So this is here current is I1. I2 is flowing opposite side. So V0 is equal to, V0 is a drop across 2 ohm resistor. So 2 into I1 minus I2. Yes, so 2 into I1 minus I2. This is equation number 4. So we have 4 variable 1, 2, I1, I2, I3 and V0. So 4 variable 4 equation. Substitute V0 here. Then it will become 3 variable equation. So 3 variable 3 equation. Apply Cramer's rule and find I1 is 3.5 ampere. I2 is minus 0.5 ampere. I3 is 2.5 ampere. Right? Simple problem. And the last problem is 4 ohm. This is a circuit they have given. Find I1, I2, I3 they are asking. So here you see in between these two loops we have one current source. So these two loops are forming one supermesh. Here also we have one more current source. So all are forming a supermesh. So this is combined full supermesh. Now we apply KVL at supermesh. We have only supermesh. So KVL at supermesh, right? So what happens here? Here you see, let us start from here. So here current flowing is I1. So 4 I1. Next in this branch 8 current flowing through 8 ohm resistor 8 kilo ohm is I2. Here 2K, so 2 I3. Then the current encounters plus terminal, so plus 40. When you go here, here current encounters minus terminal, so minus 100. That is equal to 0. Okay. So it is KVL at supermesh. So now we have to apply KCL at supermesh branch. So what we see here for this branch we apply here it is, what is that thing, 4 milliampere Here I1 comes, here I2 goes. So I1 plus 4 is equal to I2. This is equation number 1, this is number 2. Okay, next in this branch here you see, here it is coming like this. This is 2I1, here I3, here I2. So what happens? Here I3, here I2. So it indicates I3, incoming is I3 plus 2I1, outgoing is I2. So this is equation number 3. Okay, next, is there any dependent source? So this is I1, no problem. So I1 is I1 only. Yeah, we don't need to write a dependent source in terms of something. So we got the 3 equations and 3 variables. So if we solve all the equations as per Cramer's rule, what we get is I1 is 2 milliampere, I2 is 6 milliampere, I3 is again 2 milliampere. Okay, so these are all the answers. Right, I hope you understand all the problems. If you have any doubt, please ask me in comment section. I will clarify. Thank you.